Okay, class, so grade 11s and 12s, welcome back. So what we're going to continue on, I know we were kind of halfway, I wouldn't say halfway, we're just finishing up compounds. The predicament that we have basically is that some of you have your notebooks at home, so we're not going to be able to really kind of finish up compounds. So what we're going to do is basically kind of start a new unit, and from this point forward is what you're going to be assessed on. I'm not going to assess you on anything that we did previously, although you do need some of that knowledge previously. I understand that not all of you have all of your resources at home. So what we're going to do is we're going to kind of start Unit 2 right now, which is going to be reactions. Okay? So let's go through this. So you can download my slideshow, and I know I usually give you a paper copy of these. We have a couple different options that you can do as we go through these. One, you can still write things out by hand by just getting a piece of paper out and saying Unit 2 reactions, slide 1, and then write out some extra stuff, slide 2, slide 3, slide 4. So instead of actually writing it on the slides, you're just writing it on an additional page. That is one option. Now the other option is that you can download these slideshows and essentially write right on top of them using an iPad or potentially a Chromebook. The problem I have is I can't exactly explain how you do that because there's so many different formats that you guys are using. Some people are using iPads, Chromebooks, phones, computers, and then all the other different operating systems and all the different versions of the operating systems. I wouldn't be able to tell you exactly how to do it on your device because everybody's using a slightly different device, or most people are using different devices. So it's kind of up to you as to how you'd like to do this in class. I know normally I give you the slideshow, but obviously we're not going to be able to do that. Okay, so let's go through Unit 2 reactions. So the first part is just going down to some terminology. So there's three ways that we really write out reactions. We write them out as the word equations. You can kind of see here, I'm talking about originally. Let me just highlight this for you. So the first one we're going to talk about is word equations, and that's simply just using words. Like nitrogen plus hydrogen leads to nitrogen trihydride. Now, you do need to know the proper naming system. Okay, so when you produce the product, you do need to know the proper naming system. But generally, these are pretty easy formats. The tricky part is deciphering which ones are the reactants and which ones are the products. Now the second way that we write out reactions is what we call skeleton equations. Now these are pretty handy because they actually show chemical formulas as opposed to names, but they're still really not designed for chemists. They're more for the general public. So the first two equations, at least the format of those equations, are more for the general public and not essentially for us chemists. This is what we like down here. I highlight this in red, just because it is more important. And it is the way that we, as chemists, write out chemical reactions. We always want to write them out in a balanced chemical reaction. Now, if you're going to quickly write something out, it doesn't always have to be, but anytime you're formally doing a lab or any kind of procedure, we want them in balanced chemical reactions. And really that is just taking account of the masses and making sure all the atoms add up. So I've had to add a 3 here and then a 2 there in order to make it balanced. But we'll go through those in lesson number 2. The first thing we're going to talk about before we start doing those formats is just making sure that we understand what's a reactant and what's a product. Because regardless of the format that you're using, they're all going to have reactants and products. So what reactants are? They are the chemicals being mixed together, or the chemicals undergoing the reaction. So I'm going to highlight these in red here. Okay. Now they are always written on the left side of the arrow. So if we look at our three formats at the bottom, word, a skeleton, and a balanced, all the reactants are on the left side. I'm going to highlight these in red. So these are the reactants. They are on the left side of the arrow. They always have a plus sign between them, and they're going to be on the left side of the arrow. And those are called the reactants. They're the things that we're mixing together. Okay? Now, what they're going to produce is what we call products. Okay? So products are the chemicals produced from mixing the two reactants together. I'm going to take these two things like nitrogen and hydrogen together and produce a product. So products are what is produced from the mixing of the reactants. Now they are always written on the right side of the arrow. So I'm going to highlight these in green here. So these are what my products are. So you have reactants on the left side, products on the right side. No matter what format you write them in, you should always be able to identify reactants and products. And I'm going to require you to do that. Okay, so let's go through the first one, word equations. Okay? So when we want to write out word equations, these are basically, we have to take a paragraph, excuse me, and then try and write them out into more of an equation as opposed to a sentence. So if we look at our first one, it says sodium and chlorine combine to form sodium chloride. So the hard part about this is we have to identify, well, what are the reactants and what are the products. Now there's a couple ways that you can do this because it's all these different terms, but one of the words that we're looking for is this word right here when it says combine. Okay? When it says combine, that usually indicates that we're talking about the reactants. We're going to take sodium and chloride and we're combining them. So those are essentially our reactants. So if we're going to write out this reaction, we're going to start by stating sodium plus chlorine. Okay? I apologize. I know that my penmanship is not the best. It's a little bit difficult to write on an iPad. Okay, so we have sodium and chlorine combine to form sodium chloride. So they're going to produce sodium chloride. That's my reactant. So I'm going to draw an arrow, and then I'm writing sodium chloride. Right? Again, I apologize. I know this penmanship looks horrendous here. Okay, let's take a look at the next one here. Okay. So the next one is aluminum reacts with oxygen, creating aluminum oxide. So when we're trying to identify the reactants and the products, it says aluminum reacts with oxygen. So that's going to be on the left side of the arrow. So aluminum plus oxygen. And then it says that creating aluminum oxide. So that's going to be my product. And that's simply all that word equations are. Okay. Now, just to remind us over here, okay, I'm just going to do a quick circle here. These are my products here. Okay, these are the things that were produced. And then over here, we had my reactants, the things that were combined. And word equations are not the most common ones. They're very, very rarely used. It's really just more for non-science and non-chemistry people. Okay, we do have to understand them, but we don't use them very often. Okay? The other format that we have is what we call a skeleton equation. Now, a skeleton equation is a big step up. Okay, we're going to take these words, and instead of using words, we're going to actually start using chemical formulas. Now, it requires you to know a little bit about chemistry, though, or at least a little bit about science. The average lay person who knows nothing about chemistry wouldn't be able to do a skeleton equation, because when you write down something like Na, they're going to have no idea that that stands for sodium. So when we use skeleton equations, you have to have somewhat of a chemistry background. Okay, it's really more for kind of like biology students and physics people, where they know a little bit about chemistry, but not necessarily are chemists. Okay? So they're going to be using chemical formulas. We're going to actually state what elements are in there using their chemical formulas. But we're also going to, in a skeleton equation, include, well, what state are they in a gas state, a solid state, a liquid state, or a dissolved state? Okay. Now, if I look over here, I have the gas state twice. Okay, so I'm going to have to change this a little bit. Instead of the gas, we're going to put an L, and that stands for liquid state. Okay, so let's take a look at these equations, and we wrote them out as words, but now let's write them out in a skeleton equation. So it says solid sodium. So we're going to write sodium, okay, but it indicates that it's solid. So we do that by a little subscript brackets S. So it's just below the sodium. Okay, kind of where the numbers would go, but there's no numbers on sodium, so we put sodium is solid. Okay, so solid sodium and chlorine gas. Now remember that chlorine is a diatomic. It can never be on its own, so it has to be Cl2. Okay, any of the diatomics have to be. Now it is a gas, so we're going to put in G. So sodium and chlorine gas combine to form solid sodium chloride. So we write NaCl, and then we want to indicate that it's solid. And there's my solid sodium chloride. Okay. Next one, just another example. Aluminum reacts with oxygen gas. So it says solid aluminum plus oxygen gas. And again, oxygen is one of those diatomics. This is a very, very common mistake, is someone will just write plus O, but O can't be on its own. It has to be O2. And it says that's a gas, creating solid aluminum oxide. Now, aluminum oxide. We have to remember that this isn't a word, aluminum oxide, but we can't just write ALO because we didn't do the crisscrossing, and this kind of thing doesn't actually exist. So we have to crisscross, and I have to say, okay, aluminum has a 3+ on it, oxygen has a 2-, and if I crisscross, I get Al2O3, and it's a solid form, okay? So a couple key things here is ensuring that whenever you take the word and put it into the chemical formula, you ensure that you do the crisscross rule. Okay? In particular with ionic compounds, and most of the things we're going to be doing are ionic compounds. All right, just one slide left, and that's the problems with these formats. So although the above formats can provide information on chemical reactions, they are largely unused by non-chemists. Or they're largely, used by non-chemists. The average chemist like us wouldn't use the two formats that we just went over. And the reason for it is both equations do not account for the amount of each reactant required to complete the reaction and the amount of product being produced. Like if I look at the skeleton equation of Na plus Cl2 leads to NaCl. Well, if you look, that's 1 atom of sodium combining with 2 atoms of chlorine, creating 1 molecule of NaCl, and that molecule only has 1 sodium and 1 chloride. Well, where did the other chlorine go? Okay? It doesn't account for this. So that's why skeleton equations are a problem for real chemists. As real chemists, we have to account for, well, where did that other chlorine go? It can't just disappear. Like technically, when we write out this reaction, that's impossible. There's no possible way that 1 sodium can combine with 2 chlorines to make only 1 sodium chloride molecule. That's impossible. The other chlorine has disappeared, and that's not possible. So these are the problems with the first two equations. Now, we let the general public use them because it's simple and it allows them to not have to require this extensive knowledge of balancing. But again, as chemists, we don't usually use these two equations. So I'm going to upload a learning check for these two, and that will be posted tomorrow, where we can practice ensuring that we know how to write out word and skeleton equations. Okay, thanks guys.